All right, number 6 is an outside angle, which means we have to use that formula that the angle, the angle is equal to 1/2 of the major arc minus the minor arc. Okay, so my angle is 70 degrees, is equal to 1/2 of my major arc, which is x, minus my minor arc, which is 61. Multiply both sides by 2 to clear my fraction. So now I have 140 on the left equals x minus 61. I need to add 61 to both sides, and I get 201. So the value of that arc is 201. All right, I know you need 13 and 14. I might have to do some work to get there. So I'm going to start at the very beginning. So I know part of my givens is that this arc HD is 50. So from there, what I did was I knew then I followed this angle here, this inscribed angle. So now I know that this has to be 25. I have a radius intersecting a tangent. I know that's 90. Let's see. If I focus on this triangle right here, if that little angle up here is 25, this one's 90. So this one has to be 55. No, 65, sorry. That has to be 65, which makes this vertical angle 65. Then I can use my linear pairs there. So I get, let's see, 115. Sorry, my son's in the bathtub, if you can hear that. Let's see if that helps us with GB. Not quite yet. If we go up here to this angle, I know that that red angle I just marked and this 25 here, that has to be a total of 90. So that has to be 65. I know this is a right angle, so this has to be 25. Let's see. Then, let's see, what else do we know here? I'm sorry. All I can hear is my son in the bathtub blowing bubbles. Okay, so I'm going to look at a big triangle. I'll take 180 minus 25 minus 38. So I'm looking at this big triangle here. Okay, so I just solved for this angle right here. I know that should be 117. All right, so then using my linear pair, I know this angle is 63, which then that is an inscribed angle that opens up to this arc here. Sorry, this arc. So this has to be 126. All right, so now this will help me get GB because I can look at this outside angle here. This outside angle is equal, the angle itself is equal to 1/2 of the major arc minus the minor arc. And GB is that minor arc that I need. Okay, so, oops. So we know that 25 should be equal to 1/2 of 126 minus x. That x there is GB. All right, so multiply both sides by 2. We have 50 equals 126 minus x. If I subtract 126 from both sides, I end up getting 76 is x. So GB here is 76. Okay, so I know you need GB, and then you need a GBD. So GB to D. All right, so we're talking all the way here. So I have a semicircle plus another 76 that I just figured out. So I really want to do 180 plus 76. So that gives me a total of 256. All right, this problem here, the easiest way and the fastest way to do this is, because we have two tangents, is to make, let's see here, make radii that go to that point of tangency. Because then this makes our kite, and this arc is also the measure of my central angle. Okay, and what we know about the outside angle and that central angle is they're supplementary. So I can just do 7x plus 19x minus 2 equals 180. All right, so combine my like terms. I have 26x minus 2 equals 180. Add 2 to both sides. I get 182. So then 182 divided by 26 gives us 7. Then I just really need to plug that back in. So 7 times 7 is 49. That's the easiest by far to do it. If not, what you have to do is you have to come up with an expression for this major arc. So it's going to be 360 minus that minor arc. So that's minus 19x minus 2. Here's what that equation is going to end up looking like. It's going to be 7x equals 1/2 of my major arc, which is 360 minus 19x plus 2. Now I still have to subtract that red major arc. So I still have to subtract 19x, and I have to subtract a negative 2. That's the equation you'd have to use if you want to use that outside angle equation. Again, though, that kite is way, way easier. Okay, this is another outside angle problem. So the outside angle, remember the outside angle is equal to 1/2 of the major arc minus the minor arc. Okay, so my angle in this case is x plus 55 is equal to 1/2 of, my major arc is 155, my minor arc is x plus 45, so I have to subtract both of those terms. All right, so now I'm going to multiply both sides by 2. So I'd have 2x plus 110 equals 155 minus x minus 45. So I have 2x plus 110 equals, if I combine my like terms, I have 110 minus x. If I add x to both sides, I'd have 3x plus 110 equals 110. Subtract 110, I have 3x equals 0. So in our case here, x has to be 0. Okay, on this problem here, what you have to remember is we have what's called a cyclic quadrilateral. Okay, so it means those 4 vertices are on the circle there. Okay, and what's so special about that is the opposite angles are supplementary. So these 2 angles here, we're going to add together to be equal 180. Now, these 2 angles are also equal to 180 if we add them together, but I don't know enough about this angle over here, so I really have to focus on these 2. This 16x plus 21 is just a distractor. All right, so I have 27x minus 18 plus another 22x plus 2 equals 180. Combine my like terms, I have 49x minus 16 equals 180. Add 16 to both sides, I get 196. Divide by 49, and we should have 4. Okay, yep. All right, so then that's all I wanted in that one. So x equals 4. All right, so this one, it says a Ferris wheel has a diameter of 42 feet. How far will a rider travel during a 4-minute ride if it rotates once every 20 seconds? All right, so first of all, think about your Ferris wheel. Its diameter is 42 feet. So I know my circumference is 42 pi. All right, now we got to think about, it's not going around just one time. It's going around a lot, right? It's going around for 4 minutes. Okay, so each minute, every minute, it actually goes around, it goes around once every 20 seconds. So that means it goes 3 revolutions in 1 minute. So for 4 minutes, it's going to go around 12 times. So the distance it's going to travel is 42 pi times 12 revolutions. So if you multiply that out, 42 times pi times 12, you get 1,583.4, let's see, what are we in, feet.